Today we looked at a series of physical and chemical changes without actually knowing the definition of either. Perhaps you already know, but we didn't define them as a class before doing this activity. So we're going to look in this video at a series of chemical and physical changes. After the chemical or physical change happens, write down some observations in your spaces here on page 3. Now, we're not going to do all of these. We didn't do all of these in class, but write down some of them that we do in the video. So we're going to actually start off with some of our chemical changes. Now, we're not going to do the burning paper one, but we will do the glow stick one. So it's pretty bright in here right now, but we can make some observations about our glow stick. Now, if we look in the dark, we can see it is not glowing. So we're going to go ahead and break it, and we're going to see what happens. So we can see we have that glass capsule in there sliding up and down. That is where one of the substances in our glow stick is. So let's go ahead and break it. Not the easiest thing to do one-handed. There we go. Now I'll shake it up. And now we can clearly see in the dark that that is glowing. So write down some observations on your paper next to where it says glow stick under chemical changes. What did you see happen? Next, we're going to take a look at ice melting on the physical change side. Now, this piece of ice has been sitting out for about 5 minutes. We can already see that it is indeed melting. It's getting very wet and very shiny. We can see that there's a bit of a puddle forming. So write down some observations about the physical change of ice melting. And that is on your physical changes section here. Next, we're going to move down to another physical change, paper tearing. So again, kind of tricky to do one-handed. My other hand is holding the phone for a camera. So let's go ahead and tear this in half. And we have our paper torn in half-ish. Write down what you saw. Next, we're going to do a kind of weird one. We have cabbage juice. Ooh, yum, not yum. Cabbage juice is just made from cabbage, cabbage leaves, specifically red cabbage leaves. It was made just by soaking those red cabbage leaves in some water. So here we go. Here's the red cabbage leaves. Ooh la la. You can see all the pigment in the leaves is actually coming out into the water around it, which is pretty cool. So actually, let's replace this, because why not? Let's get some fresh cabbage juice. Yeah, it smells like cabbage. Yum. So we have this purple cabbage juice in this pipette. This is called a pipette. And we're going to add this to citric acid, which is right here. Now, citric acid is this stuff right here. Citric acid. This is just something I have in my kitchen because I have some random stuff in my kitchen. And it is very sour tasting. You'll notice, right, there's little lemons here because citric acid is what makes lemons sour. And so we're going to add this purple stuff to this white stuff. It kind of looks like little sugar crystals. So you ready? Okay, so you should be writing down what you observed in this spot here, mixing cabbage juice with citric acid. And here we go. One thing you want to be asking yourself is, does this color change make sense based on what you know about colors? Does purple plus white equal pink? If your answer is yes, well, try again. Should be no. Purple plus white does not equal pink. Right? Red plus white equals pink, not purple. All right, so now we've done the cabbage juice with the citric acid. We're actually gonna do something else with this cabbage juice, and we're gonna add it to our baking soda. So this right here is some baking soda. We're gonna add our cabbage juice here. Now, before when we added our cabbage juice to a white substance, it turned this lovely shade of pink. We're now gonna add this purple substance to this white substance. It looks a little bit different. This like, kind of looks like a powder. Add this here. Let's see what happens. So, all right, it started off this purple color, and that has clearly been a color change, right? So this purple changed to pink when added to this citric acid, but more of like a blue, almost green color when added to the baking soda. Let's add a little bit more. All right. Pretty drastic color change. All right, so take some observations under our mixing cabbage juice with baking soda section. And now we're going to do our last one that we'll do together. You can fill out some of the other ones on your own here, right? You can imagine what happens when aluminum foil, when you crumple it into a ball, right? You can imagine what happens when water is boiling. You can imagine what happens when paper burns. But now we're gonna do our Alka-Seltzer, which is this little half tablet right here. And we're gonna put it into some water. Now this is often used for like indigestion. A little bit of Tylenol in it actually, which is not the active ingredient here. But we're just gonna add this to the water and see what happens. So this, just like the previous two that we did, the baking soda and cabbage juice and citric acid, this is also a chemical change that we see happening. Take a look at it from the side. Very fizzy, very bubbly, and that's it. So at this point, you have made these observations. Here's our tray. Remember, that ice is really getting melty over here. We have our torn paper. We have our very glowy glow stick. We have our citric acid that's turned pink because of cabbage juice, our baking soda that's turned bluish green because of cabbage juice, and our very, very fizzy water thanks to our Alka-Seltzer. And at this point, you should be able to answer the remaining questions on your paper. There are 3 more. Thinking about, how do we know? How do we know if something is physical or chemical? What stood out about the chemical changes over here versus the physical ones? What did you notice that the physical changes had in common or that the chemical changes had in common? And that's it.